The next scenario is order of operations. So what is the meaning of order of operations? So order of operations means if you build any visualization in Tableau, which order Tableau will follow, which order Tableau will follow while executing. So till now we have seen individual things like defining filters, defining calculations, and adding the forecasting, adding the reference line. So we have seen so many things. At the individual component level, we have seen how will they execute. For example, in the LODs, we have seen how the filters will execute. Okay. So if we integrate them, if we integrate everything in the form of a visualization or in the form of a dashboard, which order Tableau will take. So what is the query execution order or what is the Tableau query pipeline? Okay, that we should know. So in this order of operation scenario, I will discuss the Tableau query pipeline. Okay. So if you build any visualization, what is the query pipeline followed by the Tableau and why it is important, and also what are the common scenarios we will do during that order of operations. So basically, I will discuss few examples also. Okay, basically I will discuss few examples also. So if you take the query pipeline, the Tableau complete query pipeline looks like this. We take the complete query pipeline. The Tableau query pipeline looks like this. So the Tableau query pipeline contains, the Tableau query pipeline contains the complete objects. So if you define the filters, so the filter which is having the highest priority is the extract filter. So basically extract being the data source, at the data source level if you define any filter, okay, that will execute first. Because here all these filters are going to, here all these particular query pipeline, they're going to query the data source and they will fetch the or they will retrieve the required data, right? So how Tableau communicate with the data source using SQL? So in SQL, if you take SQL, what are the different classes we are having? The different classes we are having are select class, from class, where class, group by class, group by, having and orderable, having and orderable. So what this select contains means, select it contains list of required or all columns. It contains list of required or all columns. Select class contains the list of required or all columns. So from where the select going to select means from the data source. So where we specify that data source means in the from class. Basically from class contains the data source. It contains the data source. And next, where class. What about where class? Where class it contains conditions. It contains conditions on the ungrouped data. So ungrouped data means without an aggregation or unaggregated data. It contains conditions on the ungrouped data. Where class contains the conditions on the ungrouped data. So in Tableau, if you take the fields, so which field data is ungrouped? Dimensional data, because if we drag and drop any dimension, what Tableau going to show us? Tableau going to show us each and every value of the dimension, right? For example, here I'm taking one field. Here I'm creating a new sheet. So if I drag the city, Tableau going to show us each and every city value. Here Tableau going to show us each and every city name. So it means what Tableau is showing us the row level data. In each and every row, Tableau is showing us one value. Whereas if you take any measure, Tableau is taking what? Aggregation on that measure. Tableau is taking the aggregation on that particular measure. So it means what, by default the measures contain the aggregated data. So where class contains conditions on the ungrouped data. If we talk in specific to Tableau, all the dimensional filters, will be part of the where class. And next, group by. What group by contains? It performs the data grouping. What does it mean? Okay, what does it mean? For example, I would like to select state-wise average sales. So how to get the state-wise average sales? Okay, how to get the state-wise average sales? If you want to get the state-wise average sales, you have to make use of select state comma average of sales from, let's say my data source name is A. Okay, if you want to select the state-wise average sales, select state comma average sales from A. But here one rule of thumb for the select statement is in the select list we cannot mix aggregates and non-aggregates. In the select list we cannot mix aggregates and non-aggregates. So all the columns in the select must be aggregate or non-aggregate, but not both. Okay, the select list should contain aggregate or non-aggregate columns, but it should not contain both. Even though if your requirement is to place both the aggregate and the non-aggregate columns, so the rule is just take all the non-aggregate columns into the group by class. Just group all the non-aggregate columns into the group by class. So we have to take one group by state. Now it is valid. Okay, because if we take state and average sales means, let's say we have 10 states, and if we take average sales means it is going to give us what? The average of all the states, right? But if you here your requirement is to see every state with average sales. So how to get every state with average sales means we have to group the data. Here we have to group the data for every state. So how to group the data for every state? We just simply want to take that into the group by class. So one simple thumb rule is in the select list we cannot combine, or we cannot take okay, aggregate and the non-aggregate fields. Even though we want to take the aggregate and the non-aggregate fields, just take all the non-aggregate fields into the group by class. Next, what about having? Having class, it contains conditions on the group data. It means the measure filters. If we define any measure filters, all the measure filters will be part of having class. And finally, order by. Just simply it performs ordering of the data. Ordering means either ascending or descending. It is going to show the data either in the ascending order or in the descending order. And so finally to see the execution order. So we have seen the description of different class. Select from where, group by, having, and order by. So how will they execute? So what is the execution order? What is the execution order of these different classes? So the execution order is always the execution starts from the data source, because without the data source we cannot select, without the data source we cannot perform any filtering, and without the data source we cannot perform any data grouping. So always the execution starts from the data source. It means from the from class. Okay, from the from class or from the data source, the execution will start. So if we take any SQL statement, how it will execute internally means always the execution will start from the from class. So in the from class, if we take any filter, it is called as the data source filter. So next, after from class, the class having the highest priority is where class. Okay, the class having the highest priority is where class. And because the where class contains the ungrouped data, it doesn't require any data grouping. After where class, the execution will go to the data grouping. So where will perform the data grouping on the group by class. After performing the data grouping, it is going to execute all the grouped data. So which will be part of having class. And after execution of all the grouped conditions, finally it is going to select the data and finally it is going to perform order mode. It is the execution order. So first always the execution will start from the from class, next where, next group by, next having, and finally select and the order by. So if you take the extract, so where the extract will come? Extract will comes under the data source, right? So as the extract comes under the data source, so first in Tableau the execution will start from the extract filters, and after the extract filters, then the execution will goes to the data source filters. So after the data source filters, then the execution will goes to the context filters. Next here in the filter execution sequence we have seen these three, and next in the filter execution sequence what we got the dimension filter. But before the dimension filter and here after the context filter, here one more thing will come, that is data blending, because here I'm talking about on the whole of Tableau. Okay, next the data blending going to execute, so after that data blending, next before the dimension filters in the LOD you have seen the fixed LOD will execute, right? In the LODs we have seen before the dimension filters the fixed LOD will execute, because fixed LOD going to create the fields of type both the dimensions and measures. So along with that fixed LOD, if we take sets or if we take any conditional filters or if we take any top end condition or if we take any top n condition, all those objects will execute, before the dimension filters and after the data blending. Okay, before the dimension filters and after the data blending, and this dimension filters will execute after that, and after the dimension filters, next include and exclude will execute, and next finally the measure filters will execute. So we take the dimension filters, so where the dimension filters will be part of in the where class. Means what, first where class will execute and after the where class, okay, the measure filters will execute. So the measure filters will be part of what, having class. Means first the measure filters will execute and after the measure filters, next the having class filters. Sorry, first the dimension filters will execute. So as the dimension filters are part of the where class, after that the measure filters will execute as the measure filters will be part of the having class. So one important interview question is, in fact, the most important interview question: what are the differences between where class and having class, and which class gives the good performance? So we talk about the difference between where class and having class. Where class always contains conditions on the ungrouped data. It's the point number one. And having class contains all the conditions on the grouped data. And point number two is in where class, okay, yeah, you see the where class. The where class is not dependent on the group by class. So as the where class, it doesn't require any aggregation. Where class is independent on the group by class. What about having? Having, it contains the conditions on the grouped data. First of all, we have to perform the data grouping, right? If we want to implement any conditions on the grouped data means, first of all, we have to perform the data grouping. So how to perform the data grouping using the group by class? So it means the point number two is where class is independent of the group by class, whereas having class is dependent having class is dependent on the group by class. So it means the existence of where it doesn't require group by. Where can exist without group by. Okay, where class can exist without group by. Whereas existence of having class it demands group by class. So if you want to take the group by class means okay the group by class should exist. The group by class should exist. And the third point is where class always gives the good performance compared with the having, because where class directly going to perform the filtering on the row level data. Where class directly going to perform the filtering on the row level data, whereas having class it is going to perform the filtering on the grouped data, on the combined data. Okay, so it means if you want to perform filtering using the having class means if you want to perform filtering using the having class means first we have to perform the data grouping. First we have to perform the data grouping. So it means if you want to implement having class, first we have to execute group by, then next we have to execute having. So let me repeat again the 3 points here. Where class contains conditions on the ungrouped data, whereas having class contains conditions on the grouped data. So point number 2 is where class it is independent of the grouped class, whereas having is dependent on the grouped class. And point number 3 is where class gives the good performance because where doesn't require any data grouping. So whereas having class gives the less performance compared with the where, because if you want to implement having, first you have to implement group by, then next you have to implement having. And if you see the priority, always the where class comes first, then the having class. These are the 4 important points. So next, so after the measure filters, after the measure filters, if I add any forecasting, we are seeing forecastings, right? So if you add any forecastings, so next the forecasting will execute. After the forecasting at the end, the table calculation will execute. And after the table calculations, okay, if you add any trend lines or if you add any reference lines, okay, the page, it means the animations, next tooltips, titles, annotations. All these things they're going to execute at the end after the table calculation. So about this trend lines, reference lines I will discuss. Okay. So after the table calculation filters, at the end, these animations, tooltips, titles, trend lines, all these things will execute. So you see till here, till the measure filters, all these things that are going to execute as a part of query at the data source level. All these things are going to execute as a part of the query at the DS level. DS means at the data source level. And from the forecasting till the bottom, these are going to execute at the Tableau level. Okay, post query these are going to execute. Okay, post query they are going to execute at the Tableau level. Okay, post query these are going to execute at the Tableau. The 8 extract data source filter, number 2, number 3 context filter, number 4 data blending, number 5 sets condition filter stop and fixed LOD, number 6 dimension filters, 7 include explore LOD, 8 measure filters. These 8 they are going to execute. As the part of the underlying query at the data source level. 9th is forecasting, 10th is the table calculation filters, 11th is the trend lines, reference lines, phrases. So all these things they're going to execute okay at the level of the tableau. The 9, 10 and 11 they're going to execute at the tableau level. And first 8 they're going to execute as a part of the underlying query at the data source. So based on this query pipeline, so it's a query pipeline in 9. So what about in 8? In 8 also it is same, but in 8 we are not having LODs, right? So here we don't have LOD in 8, and we don't have an include and exclude LOD in 8. So apart from these LODs, in 8 also the query pipeline is same. In Tableau 8 also the query pipeline is same. So let's start working with, some common scenarios. So to understand it in the better way. Let's start working with some common scenarios. So I'm having a task, where I would like to show, the top 10 products in each city. In each city, I would like to show the top 10 products. So we click on any city. In that city, I would like to show what top 10 products. So here how many filters we're having? We're having two filters. One is the city filter and other is the product filter or the description field. So you have to take these two fields and you have to take the top 10 products and the city field. So let me build this. Let me build this. There my requirement is to show the top 10 products in each and every city. So I'm taking city first. Next, how to get the top 10 products? To get the top 10 products. Okay, the product will is the description field. Drag the description and drop it into filters. Okay, now just go to the top by field. So top 10 based on total sum. So total means the total revenue. Total is the metric here. Click on apply and click on OK. So now just drag the description and drop it into the rows. Next just drag the total and drop it into columns. So just let me add a filter on one city. Let's say for example I'm clicking on this city. So in this city we can able to see the 10. Let me select some other city. In this city here Tableau is showing us only 8. Why it is showing here only 8? So just we will think in the next level, not in the visualization level. So here we have the filters, right? Here we have two filters. What are two filters? Description and city. So what type of filters? These are dimension filters. So they're part of what? They're part of the these dimension filters, they're part of the where class, right? So here what type of dimension filters we're having? One is the top end filter. City contains description contains what? Description contains the top end. So basically we can able to filter a dimension in 4 ways, right? Like general, wildcard, condition and top. So if we define all the four, first which one will execute? So first which one will execute means this top end and condition, they're having the highest priority when compared with the general and wildcard. When compared with the general and wildcard, condition and top are having the highest priority. Okay. Next on the city here, what we have defined? On the city here we have defined the general filter. If we go to city, here the city contains what? The general filter, right? So if you see the query execution, you see the query pipeline, here. So what it is happening here is, so if we define the top end, if you see here there are two dimension filters. One is city and other is what? The product. So the city contains what? Normal dimension filter, and the product contains what? Top end filter. Among those two, among the general and top end, which is having the highest priority means the top end is having the highest priority. So first top end is executing, and after the top end, next city is executing. But here what we want, But here what we want? Here we want the top 10 products in every city. It means first we have to execute the city filter, and after the city filter execution, then in that city we have to get what? The top 10. So it means what? First we have to execute the dimension filter and then we have to execute the top end filter. So how to reverse it? So how to execute city first, then how to get the top 10. So already we have seen this type of task with the context filters. So it means here we have to take city as the context filter. Just define city as the context filter. Just define city as the context filter. So what will happen if I define city as context filter? If I define city as context filter, so first the context filter will execute, and after the context filter, next this top and will execute. Just go here. Okay, just I'm defining the city as the context filter. Just add to context. So if you add to context on the city, here we got how many? Here we got how many products? We got the 10 products. Okay. So now here we have again two filters. Now here again we have two filters, city and product. Here again we have two filters, city and the product. So city is of what type? City is of type context and description is of type normal filter. So first the context filter will execute and then the top end filter will execute, right? So it is the okay. In this way, we have to do the required workaround. It is a basic task. Basically, we know that the two filters will work independently, right? The two filters will work independently, so we cannot get the accurate result. So here we have to make the description depending on the city. Here we have to make the description of the product depending on the city. So how to make the description depending on city means we have to take city as the context filter. Next task. Let me go to the next task. The next task is, in my next task, I would like to show what are the top 10 products. What are the top 10 products in each city? What the first task? The first task is same. Okay, the top 10 products in each city. So to this task, here I am adding one more condition. What are the top 10 products in each city with an average bottle price greater than $15? Okay, with an average bottle price greater than $15. So how to build this? How to build it? Just here I'm taking, let me build it from scratch. So I'm taking city, top 10 products in each and every city. So I'm taking city. Next here I'm taking description. Right. So next here I'm taking total. So we have to get okay. So here you have to get the top 10 products in each and every city. So if you don't understand the question in the proper way in BI, so as I have told already in BI, in the business intelligence, understanding the question is the okay is most important. So here let's divide or break down the question into two parts. You know how to get top 10 products in each and every city. So just take city filter and make it as context. Click on apply, click on OK and make it as context. Right. Select any city. Select any city. Next drag description and select top 10. Just go to top, select by field, select top 10 based on total sum. Click on apply, click on OK. So now here we got the top 10 products. Here we got the top 10 products in each and every city. Alright. Next here we want to get here along with that we have one more condition, that is average bottle price is greater than $15. So how to do that? Just go to the measures. In the measures you are having that condition. Just take the bottle price and drop it into filters and take the aggregation as average. Just click on next. Average bottle price greater than $15 means just go to at least. At least take 15.01. Okay, just go to at least and take here 15.01. Click on apply and click on OK. Here how many here tab will show in this here? Here Tableau is showing us only 2 rows. But here what we supposed to get? Here we supposed to get the top 10 products in each and every city with average water price greater than $15. First of all, let's try to understand how it is executing internally. Okay, here we have 3 types of filters: context filter, dimension filter, and the measure filter. Right? So we go to the execution order. So first the context filter will execute. Next the top end will execute because top end is on the product. And after that the measure filter. Okay, the average bottle price will execute. So if you understand the question in the proper way, here what we want to get here, here we want to get the top 10 products. Here we want to get the top 10 products based on what? So top 10 products based on top 10 products based on, okay, so top 10 products based on city. It means in every city we want to get the top 10 products, and also whose average bottle price is greater than $15. So it means the top 10 has to be dependent on what? This top 10 has to be dependent on the city filter and also average bottle price. So we have to compute the top 10. We have to compute the top 10 after getting the city data and after getting the average bottle price. What is happening here in the default execution order? Here first city is selecting. After city it is selecting top n, and on the top n it is picking up, okay, so whose products whose bottle price is greater than, whose average bottle price is greater than $15. So in the normal way it is picking like this. But here how we want to convert this? We have to convert this first city, okay, all the products in the city and then their bottle price greater than $15, and on that we have to get what? Top end. On that we have to get the top end. So how to do it? Okay, how to do it? So if you see the query pipeline, so always the measure filters. So measure means what here? Total. It contains aggregation. So always the aggregation filters comes only after the dimension filter. So we cannot take this measure filters above the dimension filters. So here what are the workarounds we are having? Here the workarounds we are having is first set context, then set the, okay, average bottle price, and on that just get the top end using the table calculation. So we remember or not, in the advanced calculations using the table calculation, we have extracted top n and bottom n, right? Using the index function or using the rank function, we can able to extract the top n or bottom n. So just try to extract the top and bottom n using the table calculation filter. So using the table calculation, just try to extract the top and bottom end of the, just here. So here I'm taking, so let me remove this top n. And let me remove this bottle price. So in the city here we got, in the city dot here we got 35 products. Let me drag the bottle price. Let's see here how many products bottle price is more than 15. So here we are seeing quite a few. Here we are seeing 1, 2, 3, right, 4 and 5. So if you see here the 5 items bottle price is more than 15. So if we don't have 10, we have to show how many product bottle price is more than 15. So just take the average bottle price, drop it into filter, just take average, select average, and here take 15.01, click on apply, click on OK. So here we got all those fine. Okay, fine. So as here we have to get the top n, as here we have to get the, so basically this city contains only 5, whereas if we go to some other cities, some other city contains more than 10. So here we have to get how many? Here we have to get only the top 10. So to get the top 10 here, I am using the table calculation function called as rank, and I am taking index. Just I am using the index function. I think already I am having the filter name rank. Let me use rank underscore product. Just click on apply, click on OK. Just drag the rank underscore product and drop it into the rows. Okay. Just convert this to discrete. So it is showing the rank like 1, 2, 3, 4, 5. So we choose some other city. It contains 16, whose average bottle price is more than 15. Here we got 16 items. So on this we have to get top 10. So how to get top 10 on this? Just simply go to the table calculation, okay, and just change the addressing. If you remember the table calculation theorem, what table calculation theorem states? The table calculation theorem states that each dimension will be used to specify the required partition, or each dimension will be used to pass the required values, right? So here I am using the advanced. So you have to find out for every city, I am selecting here city into the addressing and description of the addressing, because I want to restart for every city. So if you want to restart, that field you have to take in the top in the addressing, and here you have to give the ranks depending on the highest values, right? So it means you have to perform sorting. In the descending order of the total revenue. So just hit OK, and restarting every click on city. Just click on apply and click on OK. Now just add a filter add a filter on the rank. Just here we have 16. Just select up to 10. Unselect other remaining, select up to 10 only. Click on apply, click on OK. So here we got the top 10. Here we got the top 10 products. Okay, top 10 products whose average bottle price is more than okay $15. So let me choose any other city. Algona. Here also we got the top 10 products in this Algona city, and here the average bottle price is more than $15. Here what we have to understand now is how it is executing here. Okay, how I'm removing the bottle price because it's not required, just to show you guys I have taken that bottle price. So here the basically how it is executing internally. Here we have context filter, next the measure filter, and next I'm offering the top and using what? Table calculation. So here it is indicating with the delta. So what the delta will indicate? The table calculated fields. So first the context filter is executing. After context filter, the measure filter is executing, and after the measure filter, next the table calculation filter. So on the rank we have taken one filter, right? Next the table calculation filter is executing. So these two, context filter and the measure filter, they're executing at the data source level, and the table calculation is executing at the tableau level, right? So it's about the second task. Let me go to the next task. The next task is, in this task I would like to find out the average number of bottles sold per person per county. Okay, in this task I would like to find out the average number of bottles sold per person per county. So for one person, what is the average number of bottles sold in every country? So how to find out this? Let's say for example, let me explain by taking some simple example. So let's say here I am having number of bottles per county. Per county is, let's say, let's say 5,000, and population per county is, let me take the total bottles. The total bottles is 5,000, and total population. So the total population would be 3,000. Okay. So the total bottles per county is, the total bottles per county is 5,000, and total population per county is, 3,000. How to get the, here the average number of bottles per person? So if you want to get the average number of bottles per person, if you want to show the average number of bottles per person, so it is equivalent to total bottles divided by total population, right? It means 5,000 divided by 3,000. So which is close to, okay, so which is close to 1.67. Let me take one more example. Let me take the competitors are, 1,000, and number of jobs available is, 100, and number of jobs available is 100. So what about the competition per job, or the total jobs, not number of jobs, total jobs, total number of jobs. Total number of jobs available is, 100. So what is the competition per job? You want to see the competition per job, or you want to see the average number of persons per job? You want to see the average number of persons per job. So it is equivalent to 1,000 by 100. So it means 10. So for one job, the competition is 10. So it is 1 is to 10. It is 1 is to 10. So in that way, here we have to find out the number of bottles sold per person per county. Per county, what is the average number of bottles sold per person? So here in our data source, here basically we are having just the bottle sold. Okay, basically here with the help of if you see our data source, it contains, basically, yeah, we go here. So it contains, here I'm having one data source which contains the, the bottle quantity. Here we have the bottle quantity, and here we have one more data source called as the population. So if we want to find out the number of bottles per person, means here we need to know two things. Number one, what is total population, and what is the bottle quantity available. Okay, what is the bottle quantity available? So here we got the information from two data sources. One data source is giving us, the bottle quantity information, and the other data source is giving us population information. So from the liquor sales source, I'm taking here county, right, and I'm taking here bottle quantity into my text. So these are the bottle quantities available in that county, and just I'm going to the population. So now from the population I'm taking 2010 population. I'm comparing with the 2010. Okay. So in 2010, like we have, we have on this county we have the population of 7,682, and the number of bottles available are 50,886. So here how to get the average number of bottles per person? How to get the average number of bottles per person? You want to get the average number of bottles per person, you just simply take sum of bottle quantity divided by, sum of bottle quantity divided by sum of population. Okay, 2010 population. Just click on apply and click on OK. Just click on apply, click on OK. So now once if you drag that average number of bottles per person and if you drop into the measure values, here we can able to see 7 because 50,000 divided by 7,000 close to 7. If you want to see the accurate value, if you want to see the accurate value, just go to the default properties, number format, number custom and just hit OK. Okay, and just hit OK. Here where we can able to see the average number of bottles per person, right? And next I would like to see their total sales or the total revenue. Once drag the total. If we drag the total, here we can able to see the total. Here basically we can able to see okay the total revenue per count. I would like to see how much it is contributing to the total. It is the total revenue at the county level. Here what I would like to do is I would like to take the complete total of all the counties and I would like to find out their percent of total. So percent of total means what? Each and every value contribution okay has to be compared with the total value. So how to compute that? Just simply right click on the total. Just go to quick table calculation and click on percent of total. Okay, and click on percent of total. So here we have okay each and every county contribution total we got like 0.03. So for example, see the Adams contribution is 0.03. Let me add a filter. My requirement is even though if I apply the filter, okay, the value should remain same. This percent of total value should remain same. So let me select only Adams. So it is excluding that because excluded that null. Just select include values and check none. So see here for Adams here it is showing us 100%. For Adams here it is showing us 100%. Here which value is supposed to show here? 0.03. But here which value here tablet is showing here? Okay, 100%. Why 100%? So here again we have to understand the mechanism. So here we have the data blending and here we have the calculation and also here we have the dimension filter. So how will they execute in the back end? If you see here, first the data blending will execute, then the dimension filter will execute. On that, okay, output finally the table calculation is going to compute. So it means what basically where the table calculation is going to compute? This table calculation percent of total will compute at the level of the tableau, right? So if you take your county and if you take your the percent of total, first which is executing? First the county is executing because county is the dimension filter. First the county is executing and after the county execution it is computing percent of total. It means first it is getting that particular county data. On the county data it is applying percent of total. So we have only one county data means if we take percent of total, so what would be the output? That value divided by only that value itself. So the percent of total equivalent to 100%. So we click on any other city. So here it is giving us a percent of total of these two cities. But here what I want is if I even perform any filtering also, the requirement is to maintain the same output here. So here basically what is happening is so first the dimension filter is applying and on the top of the dimension filter it is applying the percent of total. So, but here what I want is I want to maintain the same value. Even though if I perform the filtering, I want to maintain the same value. So it means the requirement is to perform this computation. The requirement is to perform this computation before the dimension filter. Okay, before the dimension filter, the requirement is to compute the percent of total. So what is the other way to compute the percent of total? The other way to compute the percent of total is, so we have to take each and every value divided by total value. So how to get the total value? You can use table scope LOD, right? So I'm taking percent of total. So First of all, how to get the total at the data source level? Just take sum of total. Just take sum of total. If you take sum of total, it is going to give us, if you take sum of total, it is going to give us, okay, this total value at the level of the data source, and divide each and every total value. So how to get each and every total value? Sum of total. Just take sum of total divided by table scope. So basically, this above sum of total going to give us for each and every county, and the below one going to give us the table scope. So it is giving us errors. Once check the errors. Cannot mix aggregate and non-aggregate. Here, which is aggregated here? Here, sum of total is aggregated. And what about LOD? Even though LOD contains, the aggregated output, Tableau will treat it as an unaggregated field. It means for LOD we have to take the aggregation. So I'm taking here sum, because as I want to get the total, I'm taking here sum. Okay, it is the other way to compute the percent of total. Sum of total means each and every total value divided by table scope LOD. It is going to give us the value at the table level, right? Just click on apply and click on OK. Now if you drag the percent of total, just drag it and drop it into the measure values. So it is giving us 0. Basically it is having some decimals. Okay. So once go to the percent of total, okay, just go to default properties, number format, percentage, just hit OK. So what the percentage is Adams? The actual value is 0.03 only if you click on all. So the actual value of this Adams is 0.03. If you unselect all and if you click on Adams, now this percent of total LOD. Okay, this percent of total we call is LOD. Let me name it as percent of total LOD. So this LOD is maintaining, this percent of total LOD is maintaining the same value. So what is happening here? If you see here now here first, okay, now here first the data blending is taking place. Here first the data blending is taking place, and after the data blending, next the LOD is computing. Next the table scope LOD is computing, and it is giving us the percent of total. And finally the city filter is applying. Okay, finally the city filter is applying, and it is giving us the output. Okay, and it is giving us the output. Okay, so it's all about the order of operations. So any questions on these tasks? Any questions on these tasks? So we have few more tasks tomorrow. I'll discuss. Okay, we have few more tasks tomorrow. I'll discuss. So any questions on this concept, guys? Any questions on this task?